All right, good afternoon, good morning from wherever you guys are. My name is Amin from Somali for Sustainability, and I'm really excited to be hosting this webinar today on climate forecasting in the Horn of Africa. So, um, who are S4S? I'll give a quick introduction before we hand over to our speaker. For those that haven't heard about us, Somali for Sustainability started as just a group of young Somalis who were interested or working in the climate space and essentially wanted to make an impact and to help their communities, both in the diaspora but also back home. Fast forward to December 2023, a few of us had the opportunity to attend COI 18, which was the world's largest youth climate conference. And one of the things that we noticed was, despite the clear known climate issues that Somalia and the Somali Horn is facing, there was a lack of young people's presence at the conference. And so therefore, we decided to change that and establish Somalis for Sustainability as a community-led hub where young people can share ideas and also act as a bridge between the diaspora and back home. And so what are the issues in the Somali Horn? As many of us know, climate change is gripping the world, and we are seeing the impacts in real time. In the Somali Horn, we've seen an increase in the frequency of droughts over the past decade, coupled with flash flooding and other, natural climate events. This has been compounded by the lack of institutional capacity, as well as the inadequate financial resources that are needed to be able to respond and to facilitate initiatives that alleviate the immediate impacts of climate change. Now, as a climate organization that is youth-led, you may be wondering, what are we doing in this space and how we can help educate our community? And I'll hand over to Hussein, who give a little quick introduction about what we've been doing so far since we've established in December 2023.
Yeah, next slide, please, Amin. So yeah, so we create various sort of work streams of resources for our audiences on the sort of pressing climate-related issues and opportunities facing our community. One of them is the newsletter. So we have published 10 editions of our Mayday newsletter, which covers all things sustainability related to the Horn. We've covered topics such as Green Climate Fund initiative, migration patterns, and updates on the present state of the Horn's climate. We've also, like you are in right now, we also have worked on our webinar work stream. So we kicked it off last year, August, our first guest being Bruno Aidini from the IEA, who took us through sort of clean energy transitions with a lens and an understanding of the landscape in the Horn. Our second edition was with Hugh Salway, who was from the Gold Standard, and he sort of taught us about climate finance and carbon credits and how that helps us to realize projects that may face financial or infrastructural sort of obstacles. And this is our third edition, where we will be looking at climate forecasting with our guests from the JFA, Hannah and James. And what I'll do is I'll give a little introduction of Hannah, our main speaker, before I hand over to our guests. So Hannah wears sort of two hats. Her day job being at TikTok, a QA analyst that sort of manages AI training and optimization. And also on a sort of a passion project on the side is her work with James Fibrace Associates, and she leads the climate projects in the Horn of Africa, looking at developing Gen 3 seasonal forecasts. But without further ado, I'll pass over to Hannah to give us more of an introduction of herself and JFA and some of the work they've been doing in the region.
Thanks, Hussein, and thanks, Ami. Thanks for having us. So my name is Hannah Kader. I work, as mentioned, for TikTok as a QI analyst, train and optimize AI systems. I also partnered up with James Fibrace under the JFA consultancy, and we're working in the Horn of Africa, in the Somali Horn, to get a better understanding of climate forecasting, the gaps, and working with top scientists and engineers to get maybe a better generation-free climate prediction system, and also climate adaptation strategies. So yeah, so today, I think I'll just get started with the presentation. So today, climate forecasting for the Horn of Africa. We are going to understand the limitations of current forecasting systems, explore how AI and next generation models can close the forecasting gap and enhance the climate forecasting systems, discover initiatives approach to supporting long-term climate adaptation strategies in the Somali Horn. So today's forecasting systems, strengths and shortfalls. So here are some of the systems that already exist and their attributes. So generation 1 weather forecast usually looks at a 1 to 4 days lead time, up to 4 weeks with AI and new innovations. Forecast period, it usually forecasts the start of rainfall. So for example, if you want to go out tomorrow and you want to check whether it's raining or not, that's the type of weather forecasting used. Geographical scale, it's usually done at a local scale. Usefulness, it's good for short-term alerts. It's also used in the EWS. Generation 2, seasonal forecast, up to 6 months lead time. Forecast period is usually for the whole of the season. Geographic scale is usually at a regional scale. For example, the Eastern Horn of Africa. It's good for donor planning and for a regional average. However, it's insufficient for seasonal planning. What we're looking at is generation 3 to possibly have intermediate forecasts with a lead time of 1 to 3 months. Forecasting for the whole of the season at a sub-regional scale, 1 to 2 degrees approximately, and usefulness, it will be best for mobility and resource planning. So the early warning systems, I'm pretty sure you guys heard of early warning systems. They usually use the generation 1 and the generation 2. So generation 1 for short-term alerts, for example, there's going to be a drought in the next couple of days, or heavy floodings. It's a little too late for people to prepare. And then generation 2, it forecasts the whole region as an average. So very difficult for people to tell on a sub-regional level, 1 to 2 degrees, what's going to happen in the exact region. So it's just an average of the whole region. I will pass over to James. James, do you want to tell us a little bit more about generation 3 and the forecast gap we're trying to close?
Yeah, okay. Have I turned everything on? Can people hear me?
Yeah.
Yeah, fantastic. Well, thank you, Hannah, for that clear explanation. Yeah, so look, I'll just talk you through quickly this diagram, but to warn you, there's an awful lot of stuff in here. In fact, we're trying to portray 4 dimensions. So very quickly across the bottom here, you've got the lead time for a forecast, which, as Hannah said, could just be right down to, you know, what's going to happen in the next hour to in this area here. Can people see my cursor? Is that visible? Anyway, this first period up to 1 month, that's where we're getting to now with AI. That's what we call the generation 1B with the pushing out of AI. I'm just explaining the scale. So this scale here is the how specific, if you like, how geographically specific the forecast is, from very local, you know, these sort of weather forecasts just tell you what's happening in the nearby area, right up to, you know, the whole area. Hannah mentioned degrees, so these are degrees of latitude, which near the equator, which we are in these Somali regions, 1 degree is 113 kilometers. Let's say roughly 100 kilometers. And then the other thing is just to explain is the size of the circles gives you an idea. I told you there's a lot in this diagram. The size of the circles gives you an idea of how large is the how long is the period of the forecast. Okay, different from the lead time, which is how far ahead it is. This is, for example, right down here in the bottom corner. It might be just, you know, the forecast for the day, whereas what we're looking at is seasonal forecast for the whole 3-month rainy season. And the final thing you've got in here is this shading is an attempt to show how skilled is the jargon, how certain the forecast is. There's a lot of uncertainty. Obviously, the further out you go in lead time, the more uncertainty there is. So let's just quickly explain the diagram. The most important thing here for us is this little box in the middle here. Yeah, you've got your cursor on it, which we're calling the forecasting gap, because what people have got good at is these weather forecasts, if you like, down in the bottom left corner, and this sort of group generation 2 up here, which does indeed tell you the whole season. And this is driven, by the way, by looking at global events like La Nina is the most important one. When you've got a strong La Nina, you've got drought in the Somali regions of the Horn, and that's pretty well correlated. But it tells you for the whole region, you know, everything from northern areas of Kenya right up through Somalia and Somali region of Ethiopia, all the way up to Djibouti. And as we saw from the last rains, I don't know if anyone's been following what's happening kind of back home, but the southern part of the region got quite good rains. The middle part got very late rains, but in the end quite good. And the very northern part, so Sanaag and Seoul in Somaliland, for example, got very, very little, if any, rain. So the point is, it's not really useful. In fact, it could give them the wrong signals to say, look, we're expecting a drought in the Horn of Africa. What they really want to know is, well, which parts of the Horn of Africa? And we'll come to why that's important in a moment. Final thing on this, just to say, because this is obviously why we're looking at this in the first place, everything is getting, as Amin said in his introduction, everything is getting a lot worse. So there's another kind of forecasting, which is what's going to happen in very long time scales, 10 years, 20 years out, what will happen to the Horn. So that's a very quick explanation of this rather complex chart.
James,
over to you.
James, just quickly, before Hannah, do you want to give just a quick introduction to what El Nino is, for anyone who hasn't heard that before, that term?
To what, sorry?
The El Nino phenomena, for anyone who hasn't heard that before.
So, right, so you've got two global phenomenon, which and the world is either in one state or in the other, or kind of between the two. El Nino and La Nina. In Spanish, they mean the boy child and the girl child, if your Spanish is any good. And essentially, I'll try and capture this in one sentence, which is, this is pretty weird, but this is how it is. If you can look at the surface sea temperatures off the coast of Latin America. So you imagine you go out from Peru, Ecuador, and you're looking at how that, as you approach the coast, how that sea temperature is changing. That is driving a whole load of things. It's driving air currents and season, all sorts of major climatic events for the whole world. And that gets translated to what's called the ENSO, El Nino Southern Oscillation, and that has a very important effect on what's happening in the Indian Ocean. And then obviously the Horn of Africa is on that western edge of the Indian Ocean, and so it has a major effect on climatic changes in this region we're talking about. Does that cover it, Harmin? Okay.
Thank you very much, James. Let's get on to the current forecasting landscape in the Horn of Africa. So currently in the Horn of Africa, Chris Funk uses an Eastern Horn of Africa landscape. So this will be considered generation 2, where you forecast for the whole of the region. So on average for the whole region. So this is currently the system that is used by FuseNet, US8, and the UN. So to just give you an example, not to make it too complicated, just look at the red and the orange. So red meaning below normal MAM, below normal March to May season, and orange means below normal OND, October to December and December season. So from 2005 up until 2015, we can see 1, 2, 3, 4, 5. So 5 below normal OND and MAM seasons. From 2015, so in the last decade, we can see an increase. We can see 1, 2, 3, 4, 5, 6, 7, 8, 9. This is potentially statistics for climate change. I'm not sure how much the statistics are out there for climate change, but we can see more extreme events happening in the last decade than comparing to 2005 to 2015. So this is the current forecasting landscape in the Horn of Africa. This is what's currently available. Again, it's Eastern Horn of Africa, so it's an average. It doesn't tell you exactly on a sub-regional level what can happen and where. And we can see those issues in the last season. So the last full season being April to June of 2025, we saw heavy floods. So human fatalities were 21 plus in Somalia. People affected were 84,000, displaced 8,000 in livestock, and very significant but no official data. What we can see, for example, is that heavy floods affected a lot of parts in Somalia, despite early expectations of drier than normal conditions. So the predictions for the regions were drier than normal conditions. What we can see in Ugal is that, yes, there were drier than normal conditions. However, the onset of rain was very heavy and it was late. So because the onset of rain was very late and there were dry conditions, livestock was already very weak. So when heavy rains arrived and flash floods, a lot of livestock couldn't withhold that. And we could see a lot of loss of livestock in this region. So this just shows you that on a sub-regional level, for example, if we had a 1 to 2 degrees prediction system in the Somali Horn of Africa, we could pre-plan if we knew, okay, there's going to be drier than normal conditions in the areas of Mugan, but there's going to be heavy floodings, right? Floodings weren't even predicted. It was supposed to be this drier than normal conditions for the whole of the regions. However, rain was on time in the rest of parts of Somalia, but again, experienced heavy floods, which were not predicted. So on a positive note, let's see what and how we could maybe change that. So I will first explain to you guys how traditional numerical weather systems work, and then we will go into the numerical AI weather models that could possibly take place in a near future. So forecasting reinvented, powered by artificial intelligence. So first, how does a traditional forecast system work? So there are observations, there are weather stations around the world, there are satellites, there are ships, there are boats that pick up wind speed, that pick up humidity, and so on. These are all called observations. Now, these observations all picked up are put into assimilations, into a numerical weather forecast and numerical weather prediction system. Now, this is a physics-based model. It uses mathematical equations. And if you want to see those type of mathematical equations, you can look up ECMWF that uses those. So the European Centre for Medium Range Weather Forecasts. So yeah, those are all put into the NWP model, and then a forecast is generated. So now this is a traditional approach. Now with a numerical AI weather model, we could train the system on these observations. So we could train the systems on these observations for 6 months to a year, so use historical data. instead of running these observations every 12 minutes, which is very expensive to do. So pick up information, historical information, 6 months to a year, assimilate, train the AI system on these events, and then to possibly predict what's going to happen in the future. Now, this system already exists for generation 1. So if you want to know if it's going to rain tomorrow, you will most likely know, and there's a lot of people using this numerical AI weather model to predict that already. Sorry. But if you want to know what's going to happen in the next 3 months with a 1 to 3 months lead time, you would need a global model for this. What I mean by global model is if you want to know if it's raining tomorrow, all you need is observations that are done locally. So observations that are done locally to know if it's going to rain tomorrow or not. On the 1 to 3 months lead time, what's going to happen in 3 months' time, it's a little bit more complicated. You need a global model. So, for example, you need to know observations from across the world. To put it very simple, to train the system, if X equals Z, you need to know what happened in region X, and then 3 months later, there's a pattern, it happened in region Z, for example. So observations, for example, cloud movements, and so on. So a lot of people are working on this right now, and me and James are keeping up to date with Cambridge University and also Chris Funk in America. So people that are currently working on it, AI Weather Quest, ECMF. So ECMWF stands for European Centre for Medium Range Weather Forecasts. They're currently doing an AI Weather Quest, which everyone can take part. So if you're really good in Python code, maybe you want to have a look at this competition. Cambridge University, so Cambridge together with the Alan Turing Institute are currently working on it as well. We had some interesting conversations last week with Dr. Richard Turner. He's the professor of machine learning in the machine learning group at the University of Cambridge and research lead for AI weather predictions at the Alan Turing Institute. We're having a couple of more conversations after next week with a couple of scientists from Cambridge University. So we are pretty much keeping up to date. For medium range, what we call generation 3, there isn't a model out there yet. Like I said, a lot of people are working on it, including Google DeepMind. The professor from Cambridge University did let us know that maybe we would know a little bit more in the next 6 months to a year's time, whether that generation of medium range, sub-regional, local scale AI weather model will be available. That being said, I will give over to James to walk us through a couple of climate adaptation strategies. And I hope you understood the different generation 1, generation 2, and generation 3 weather forecasts and the potential for an IA weather prediction system.
Okay, so what this shows is why it is so important for pastoralists or the pastoralist economy, if you like, to be aware of what's coming up in terms of climate, in terms of how the next season is going to be. If you remember that little box that we were talking about earlier. I think I've got perhaps a slightly easier way of explaining this rather complicated slide. But what you've got here is down the left a number of things that could be part of an adaptation strategy in the face of climate extremes for pastoralists. The kind of things that could be done, and then why these different forecasts could be really important. But I think perhaps the best way to explain it is who are the key actors in the pastoralist economy of the Horn of Africa, of the Somali Horn. You've got the pastoralists, of course. You've also got agri-pastoralists and farmers who could grow fodder, for example, and keep animals themselves. You've got people who manage the reserves. So there's a number of people who buy the livestock, of course. There's a number of people who make up the overall pastoralist economy, and it's important to see the whole thing together holistically, if you like. But look, just to concentrate on the pastoralists, because obviously they're the most important part of all this. If they did have a forewarning of a really bad drought coming up, what can they do? I was there in Somaliland actually in 2016-17 when they had a whole, if you remember that slide that Anna showed you earlier, they had a whole succession of very dry seasons, and by the end of all that, they were, the livestock was on its knees. By late 2016, they were losing. They'd already lost about 60% of their sheep and goat. And when the GU arrives, that's the early season, the following year, it did actually rain. It was late, so the animals were very weak, the ones that have survived. And then it rained heavily, and they got soaked, and so many of them then picked up diseases and pneumonia and so on, and were killed ironically by the rains themselves. So that's what happened then. So I think that's what's motivating me. How can we avoid these catastrophic losses? The other thing that happens socially, of course, is that once a pastoralist family has lost too many of their animals and they're down to below about 30 sheep and goat, they end up as IDPs. They end up as internal refugees in the camps particularly around Bora. There's about 250,000 there now. So this is a really big social issue for the Somali regions, throughout the Somali regions. Our project tries to cover the whole of that Somali area. So just to very quickly explain what the pastoralists could do if they were well forewarned, and by well I mean accurately forewarned. First of all, they can reduce their herd size. So that's the big issue. You get these good years, you get good pasture, the herds get bigger, bigger, bigger. You get 1,000 sheep and goat in a herd, enormous great herds, and then you get the drought. They can't sell their animals. By the way, the sale period for exports of these animals is really around the two big Eids, around Eid al-Fitr at the end of Ramadan, Eid al-Adha. We've just had. That's when there's a big market in the Gulf for live animals. So reducing herd size, putting the money in their pocket, restocking later, is definitely the sensible strategy. Otherwise, it's all just lost. The other big area, of course, is planning migration. So if if we can get down to filling in that forecasting gap that we were talking about, then pastoralists could know, right, it's going to rain in this area, we can go there. It's not going to rain in this area, we won't go there, that kind of thing. I think the big sort of criticism of that is, well, aren't all the animals going to end up in the same place, and therefore just increase the mortality rate, which is why the first part I mentioned, getting those herd sizes down, is so important. And there's other things like veterinary services. A lot of the animals actually died from diseases, being weak animals all crowded together around scarce water holes. Water storage is also obviously important. And then for the farmers and the agri-pastoralists, they have an opportunity. If they know there's a drought coming up, they can plant fodder crops, and with the certainty that they'll be able to sell the fodder, and probably at quite good prices as well. So you have to think of all these together. But that's a short answer for why this forecasting area could be a real breakthrough. It's a really exciting area to be in. We're talking to these cutting edge professors about what's going to happen. I think warning, we don't know yet just how far this AI revolution, and also satellite revolution, because the sensing from satellites is getting increasingly accurate. So these kind of two parallel revolutions, and putting together the short-term weather forecast with the global climatic system, You know, it's an exciting, really exciting time. The warning was, look, you know, we can't tell you now what's going to happen. No one knows. What we know is it's happened much faster than people were expecting, but that within 6 months, a year, we should have a much better idea, and hopefully it's all in the right direction. So there's a bit of a warning there. But, you know, we think it's a really exciting area to be working on. And, you know, we'd like to hit the ground running, which is why we're doing this now, slightly ahead of the science, if you like. Back to you, Hannah.
Thank you. Like James said, we are slightly ahead of science. So our initiative's objectives encourage seasonal forecasting, aimed specifically at supporting the Somali pastoralist economy, work with both pastoralists and agro-pastoralists. We're already working with people on the ground and also with government officials. Support the development of pastoralist climate change adaptation strategies across the Somali. Thank you very much, guys. And that's it from us.
Thank you very much, Hannah, for taking us through this this sort of comprehensive review of what climate forecasting and how it's applied in the Horn of Africa. I think, yeah, now we'll open up the floor for any questions to Hannah and James. And yeah, we'll also be dropping in a link in the chat box for feedback on this session. So please do let us know what you think. And we also have our other social media handles on the page as well. So give us a follow if you haven't, to stay up to date with what we're putting out in the next coming months. But yeah, if you want to ask a question, feel free to unmute yourself. And when you do, tell us your name, introduce yourself, if you're a student, if you work, and then yeah, ask your question. But feel free to also drop it in the chat box as well.
We've got a few in there. Ibtihal, do you want to answer that? It's a fantastic question to ask. If not,
we can read it out if you want.
We'll read it out, don't worry.
Yeah.
Do you want me to read it out, or?
Sure, go for it.
Yeah, just go.
I mean, first of all, I want to thank kind of everybody who's hosting this webinar. Thank you very much. So I guess my question is, are there any traditional knowledge systems that have already been integrated into the forecasting?
Any traditional systems?
Yeah, ones that the nomads have already maybe used in the past.
That's a very good question, to be honest.
Yeah.
So the traditional systems, when we spoke to people on the ground in the very olden days, what they would look at is the wind speed, the clouds, to kind of know what could happen, but it was not too accurate, just as an average. For example, the air was moist, so in the next couple of days it could rain.
I understand.
Can I add a bit to that, Hannah?
Yes, please.
Yeah, okay. You know, I think it's a fantastic question, that because there are traditional weather forecasters in the communities, and I had the chance to speak to one about 3 or 4 months ago it's right near the border with Ethiopia and Somaliland, down that area. And he was absolutely fascinating, and he was really keen to tell us exactly what he did. So after dark, we had to wait till after dark. He took us outside the village, and you can imagine it was a fantastic starry night, just, you know, absolutely amazing, something you'd never seen in England. And he was basically pointing out different stars, and when that star goes over there and this and that, you know, then at that point the goats get sick, and then he had all these very interesting explanations. When we talk to other people, and these people I think are very respected, you know, he was a respected elder. I think at the moment, and we had some conversations in Somali region, Hannah, you might recall about this. People generally are quite wary of forecasting, and I think the reason for that is it's not, as Hannah said, it's not really accurate enough yet. Even these traditional guys looking at the stars and so on, it's not really giving the accuracy that the pastoralists need, and that is so important for them, because if the prediction is wrong, say you predict a drought and there isn't a drought, and they've sold their animals and they've done this and this and this, and it was all to no avail, or the other way around, you can imagine no one's going to believe you ever again. So I think you can only roll anything out in terms of forecasting when you've got a certain degree of confidence. I'm sure you're going to ask me how accurate in practice are the traditional forecasts. I think there needs to be more work on it, but certainly at the moment, what I was struck by was that the people themselves were taking it all with a little bit of a pinch of salt, if you like.
Thank you both, James and Hannah, for answering my question.
Thank you. I think we've got another one in the chat box from Layla. So it says, thank you, Hannah and James. I was wondering if there are any risks, downsides to using AI for climate forecasting. Is there a risk of pastoralists, local communities to not be as involved